Today I'm going to show you TRI, TRI, which is an experimental image distorter. It's a web-based app, um, and it lets you choose an image and render it using a WebGL quad, which I'll talk more about. And then you can adjust different coordinates. So the magenta are the texture coordinates. And you're adjusting those and you're seeing it render on the right through WebGL uh, in distortions, almost funhouse mirror-like. And below that there's green handles that let you change the position coordinates that set the vertices for what renders out. So that kind of changes the size and has its own distortion effects. If you do it here, you get like a fold over effect. This is one of the constraint systems experimental apps. It's a series of apps I've been doing that try and look at alternative interfaces for editing images or text. This, in a lot of ways, it follows what I've done before, but maybe more specifically than others, this is an exploration of a technology, WebGL, and really the result of me trying to understand how WebGL works was the very direct cause of this. A lot of the other constraint systems projects, I think all of them have used the HTML Canvas API to draw stuff, which has been great. Usually you want to do WebGL when you start wanting performance improvements. Because it's a little harder. It's generally less intuitive to navigate around, as I've found to be true, although it probably all depends on your frame of reference. But along with that, I found that it also has some interesting properties on its own. So a lot of this, I was thinking I wanted to do WebGL and wanted to dig into it. I've bounced off it a couple of times. I've done stuff with it through 3JS, which is a great 3D JavaScript library for using WebGL. But I think partly because I'd always wanted to do 2D stuff, I've done some data visualization, and now I kind of wanted to do 2D image manipulation. I thought a lot of the docs and stuff aren't geared towards that because that's not what most people are doing and sort of not what it's designed for, although I'm still kind of learning the history and what it was designed for. But that's true. It was always, I think, had 3D stuff in mind. So I decided to go back at it and definitely have used a lot this WebGL fundamentals site. I found to be a great resource. And specifically this, a lot of it has code from their textures examples. Um, and a lot of it was figuring out their textures. So one of the things I really like about WebGL fundamentals is it does show you, that's my dog whimpering, it does show you a bunch of 2D examples, and specifically great for me. Is it down here? Yep. They talk about how to implement draw image, which is a canvas method in WebGL. And as I did more and more canvas experiments on constraint systems, you kind of realize a lot of stuff can come out of draw image, which is just you take a source rectangle and a destination rectangle, and it draws it really quickly. You can do some blending modes on top of that. So if you do draw image and if you have a sprite sheet, then you can get a lot of different things done. And so I was reading through this and pretty much forming a plan to maybe redo some of the constraint system stuff, especially this grid-based stuff. I was actually thinking mostly of one of the earliest ones, which was Hex, where you could draw these different lines in a grid. So if I do a sprite sheet with all those um, different line shapes, and then just use this draw image function to draw from that sprite sheet, then I think I could have a working version of Hex um, pretty quickly. And the reason to do it in WebGL is you would think the performance would be better. Excuse me. So that was the plan. But in the middle of that, so I was learning how to do that and um, found these coordinates. So try is that basically. This is draw image, and here's your destination or source rectangle. Here's your destination rectangle. But in Canvas, you actually just give it a rectangle. You give it an x and y and width and a height. Here you give it an array, and everything's one of the weird things about WebGL, or maybe it's not that weird, but the performance-oriented things I think is that everything's kind of a flat array, and then in your head you have to remember kind of which goes with which corner. So for the texture source coordinates, it's a array of 12 values, and that is because there's two triangles here, three vertices each, and each vertex has an xy coordinate. So that adds up to 12. And yeah, that's just a flat array, and sort of the way it is drawn, like the order in which it is drawn, is just all kind of built in there. So that's a little weird. It's hard to get your head around because it is so flat. And basically, through the WebGL fundamentals, I had this example working, but I was like, what are these coordinates really doing? Um, and that started this journey. So first, I just plotted out these things and started changing them around. And then eventually, I don't know, I switch images as I'm talking, so there's something else to look at here. Um, Eventually, I added the mouse handles so you could change these coordinates and made sure to have both the position and the texture coordinates. One kind of fiddly thing, but not. So these are two triangles together, and actually, like where I'm clicking right now, there's two vertices, one from each triangle under there, and I ended up just pinning those together for the purposes of this. Um, you could separate those out, um, but I put those together and just update both those vertices at the same time so it keeps this together as a quad. And other than that, which I had to build a little like map to kind of go between um, more canvas-like maps of X, Y points, and just four of them for the quad, and the flat array for the triangles. And maybe this is implicit, but uh, also to really draw this out. So this was a WebGL experiment. The image on the right is the WebGL render. To do the stuff on the left, it's canvas. So I'm drawing the image and then I'm drawing the coordinates on top of it. It is basically, there's a little glue code. It is basically feeding into the same array, and it's using the same array. Like there's one state object that's these coordinates that draws these triangles in the canvas, that is used to draw these triangles in the canvas, and then it's also doing the stuff on the WebGL render. Um, so that worked well, and most of the app was, just doing like mouse events and kind of getting that all squared away. And then having done that, yeah, I am sort of impressed by how weird this group of interactions is. So like I was saying, in a lot of ways, this is just like the draw image API. The difference is it's not a rectangle necessarily. These points can be anywhere. And then if those points are sort of distorted from what the destination is different, then it stretches out the pixels. Um, and it's weird how weird it feels. It definitely feels different than Canvas. It has like a funhouse mirror appearance. And also you can double these up, which is such, it both makes sense and is weird. It really feels like it's folded back over itself, which it is, but it's also like a flat 2D space, so that's weird. This probably gets the best effects. Um, and there's a lot of ways I think once you do a quad, you in WebGL as you're doing other stuff, you kind of just treat it as a quad, as not two triangles, but the triangles do definitely have an impact. So if this triangle is short, you can see it. That line in between definitely has an impact on what you can do, which I think is interesting. As I go more into it, it'll be interesting to see if that ever comes up or if you like abstract that away because you keep the um, relative aspect of that quad in such a way or keep the line straight that it doesn't really come up. Can't totally tell, but one of the things I'm interested in here and kind of why I did this, so this was along the way of thinking I could switch images again, um, redo some of the apps for constraint systems. And then I was like, well, this is an interesting set of behaviors. My idea is, I think that like, I really want to see where the technology takes me. Like a lot of the constraint system stuff, it was like experiencing the Canvas API and then being like, oh, what does this naturally is like two charged word but like what does this feel like it wants to do, not what I want it to do. Like what is this kind of steering me towards in the conversation with that. So um, there I was like, well, I gotta check this out. I'm not just gonna like run past this and think, oh, I'll just pretend they're not triangles. I want to see what the triangles do. So then as I'm using it, I feel like I'm getting more of an intuition, but it's still a weird set of behaviors. Like I know what it's going to do in terms of when it doubles over and sort of the stretch. Um, but it's weird, and I think I'll learn more about that as I do like more things connected up, more quads connected up, then the distortions sort of chain together um, will probably show something and I'll understand that more. Um, also, like, yeah, and then so WebGL or that sort of OpenGL is what video game 3D graphics are, and I feel like I'm already um, starting to, excuse me, when I see like screenshots or GIFs of how video games look, and I follow enough like game developers that sometimes it's behind the scenes. I think I'm getting more intuition about how they work and sort of how they feel with these textures mapped differently, and then mostly they're mapped to 3D objects. Let me look at the WebGL example. Oh yeah, this is the draw image, so it's going to be 2D. Um, go back to the texture example. So I had this F, which I really like. The F is because it's not symmetrical, so you can see which way it's rotated. Um, but they put that F texture, oh, they put a keyboard texture on the F. So that's how it's mapping around faces on a 3D object. And yeah, through this experimentation, I feel like I'm getting a more like intuitive understanding of that. And I hope that's what this does for people too. Like, I hope this is fun in its own right as just like a distorter, but then I hope maybe if you're starting to figure this stuff out, um, it's pretty literal in terms of this is just drawing the texture coordinate array and the position array, um, and this then showing the result. Um, I think that's all I want to do for a run through of that. Always happy to answer questions on Twitter or wherever. And check out the larger constraint systems set of apps. Let me know if you find those interesting. I'll probably have some more WebGL coming. Thanks.